Hello class, this is the answer key for Market Process and World Economy Test 2 Summer 2013. Okay, so you see in front of you, see if I can get it to move. Yeah, this is Roman numeral 1. Neatly draw the average cost family and total cost family curves in the two panels below, and here are the panels. And this is what was given. You were given that the selling price was $8, average total cost is $8.50, and total revenue was $24,000, and you were to find the profit maximizing or loss minimizing output. So the easiest way to find that is to realize that total revenue is equal to P times Q, the selling price times output. And since the selling price was given to be $8, we can sort of work backwards, that is, take the $24,000 divided by 8. And get the profit maximizing or loss minimizing output, which was $3,000. We can do something similar to find the total cost. Since we're given the average total cost was $8.50 per unit, and we now know that the output was $3,000, we can figure the total cost was 3,000 times 8.5, or 25,500. So those two answers you get by just applying the formulas. The third one, where it asks for marginal cost, is a little more subtle because up in the givens it tells you that this is a profit maximizing firm. You know that when there's profit maximization, marginal cost intersects marginal revenue, and this was a purely competitive firm, so marginal revenue and price are the same thing. So since the selling price was $8, marginal cost would also have to be $8 if they are indeed profit maximizing. So almost everyone got those things right, but a lot of you missed the graphs. If you notice in the graphs, the price line must fall below average total cost because this firm is actually losing money. If you notice, its selling price was $8, but its average unit cost was $8.50. So it's losing 50 cents. It has a 50-cent loss on every unit that it sells. So its average total cost family needs to look like this. Hope you can see my little cursor. And if you drew it using the total cost family, the total revenue curve must pass underneath the total cost curve. Alright, so that was Roman numeral 1, and each of your little algebraic answers were 3 points each, and your two graphs were 5 points each. Alright, Roman numeral 2. Here are the answers for the fill in the missing data, but I thought it might be better to just go ahead and work it out in Excel. So here it is in Excel. Let me see if I can make it a little bigger for you. Let's see. That's about as big as I can make it. Okay, so here we go. So total revenue is just P times Q. So you can just figure it as it's that number times that number. So there are those two total revenues. And of course, when Q is 0, total revenue is 0. So that's that. And then in this case, you're given total revenue and you're working back to find the price. So this would be total revenue divided by the number of units that you had. So that gives us those three numbers. And then for these, let's do it from total revenue is easier. You're given these marginal revenues, and so you know that marginal revenue is just the extra revenue that you got when you sold the last one. So this cell right here would just be the total revenue from before plus the extra revenue that you got, and that will give us these three cells. Oops, I screwed up. That will give us these three cells right here. So let's see, now that I have those total revenues, I can figure these, or I can figure these prices. So that's that. And I can go ahead and figure out these marginal revenues. Since marginal revenue is the extra revenue you got, it would be the difference between that total revenue and the one before. So that's all those marginal revenues. And now the only place I'm stuck is down here at the bottom. This is the hardest one on the whole test. And the way you have to figure it is, you can figure that pretty easily because that's just 37.8 times 10, 378. And now can you see that you know the total revenue and you also know its marginal revenue? You can work backwards and figure this number must have been 378 minus the 27 that we got when we produced the 10th one. Or put another way, if we just decided to stop making the 10th one, we would lose $27 in marginal revenue, which must give us that number. And then using that formula, copy that down. And this number right here is just the difference in the total revenue and the total revenue from before. So there's all of our revenue functions, or all our revenue values. So the process for finding the costs are very similar. We have total cost here. This is marginal cost, or the extra cost of making one more. So this number must just be the total cost from before plus the extra cost of making that unit. And that works for these right here. And then here we're given average total cost, so we can figure that total cost, just working from the formula, must have been the unit cost times how many we made, which was that number over there. So that gives me all of those, right? And then down here, this extra cost, marginal cost, means that this cell right here must have been that number plus that. So there's my total cost. Then my marginal costs are simply the extra revenue that you get. So it would be, in this cell, be 156 minus the cost from before. So that's the extra revenue of the fourth one, and then this is the fifth, and so forth. Okay. Now my average total cost, I can just apply the formula. It's total cost divided by the number of units that I sold. Right? And then I can just copy that thing and then reapply it down here. And that should work. Yeah. So there's my average total cost. And then my profit is simply total revenue minus total cost. Right? So here are my profits. And so there are my answers for problem number 2. So the way I graded this was each one of those columns were worth 2 points, and you could get part credit. And then the 2 answers at the bottom, that is the profit maximizing output, turned out to be 5. Profit maximizing output. And the total fixed cost is simply the same thing as the total cost when output is 0. So the total fixed cost must have been 50, since when output is 0 there's no variable cost, there's only what's left over, the fixed cost. Okay, so that was Roman numeral 2. We can get rid of that now. So now let's get down to Roman numeral 3. Oh yeah, this was the Hayek airline is contemplating a new service. And what you have to realize is that the fixed cost, which was given to be the fixed cost of the hangar and baggage claim area is $5,000, that's really irrelevant because they have to pay that whether they implement this new service or not. So really, the proper business decision is made on what is the extra revenue that you get, and consider that against the extra cost. So the extra revenue was $9,000, and the extra cost is only $7,000 because the whole thing was $12,000 minus the fixed cost. So they are ahead of the game by $2,000 if they offer this service. So the answer is yes, they should offer the service because the extra revenue generated exceeds the extra cost of the service. Alright, so that question was worth 20 points. That was a tough one if you got it wrong. Alright, so then here's Roman numeral 4, the short answer, and they were 4 points each. Do monopolies charge the highest prices for which they can sell their product? Well, no, that's a really easy one. No, they don't, because the highest price would be some outrageous thing, and maybe one person in the entire world would buy the product, and they might make a lot of money on that one unit sale, but they wouldn't sell very many, so their total profit would be very small. So what they do is they set the price where marginal cost intersects marginal revenue. If you don't learn anything from this set of chapters, you should learn that. Profit maximization is always where marginal cost intersects marginal revenue. And the second one was, will firms in a price taker market be able to earn economic profits in the long run? Well, no. In the price taker market, that is the purely competitive firms, they cannot earn economic profits in the long run, because in the long run, other firms can come in freely. So if it were a possibility that you could make economic profits, all that would happen is other firms would come in, and as they did, they would compete the price down until in the end everyone was making only normal profit. Alright, and the third one was, do monopolies maximize their average profit per sale? No, they don't. To maximize average profit per sale would be probably somewhere at the very bottom of the average total cost curve. But that's not what they do. They maximize their total profit, not their average profit per sale. And their total profit's maximized, again, where marginal cost intersects marginal revenue. Number 4, suppose a price searcher is currently charging a price that maximizes the firm's total revenue. Will this price also maximize the firm's total profit? Again, no, it will not. Because if you're maximizing total revenue, I can't draw this for you in this application, but if you go back to the chapter on elasticity where they show you the relationship between total revenue and the demand curve and marginal revenue, you can see that where total revenue is maximized, marginal revenue would be 0. And since firms maximize their profits where marginal cost equals marginal revenue, it could never occur at the top of total revenue. So that's kind of a complicated way of saying no, they don't maximize their total revenue. What they do is they maximize their profits, and that's not where total revenue is maximized. In fact, if you're really good with the graphs, you should be able to see that maximum profits will always come to the left of where revenue is maximized. Alright, and the last question in this set was, monopoly is good for producers and bad for consumers. The gains of the former offset the losses of the latter. On balance, there is no reason to think that monopoly is bad for the economy. That's a clever statement, but it's false. Because even though it's true that monopolies gain and consumers lose, in the process of getting monopoly profits, there are some consumers who lose and there's no offsetting gain. It has a clever name. It's called a deadweight loss, and it's all those customers that are just below the monopoly price but above marginal cost. So basically there are some consumers, if you think about it, that will come into the store. They're willing to pay a price that's above the marginal cost to produce the product, but they're not willing to pay the monopoly price, and so they walk away. They don't buy anything. Those consumers are worse off, and the monopoly is no better off because they didn't purchase anything. Alright, Roman numeral 5. This was an algebra problem. So average total cost is simply total cost divided by output. So you can take this total cost equation here, and average total cost then would be 2Q minus 10 plus 500 divided by Q would be the equation for average total cost. Total fixed cost is simply the total cost that occurs when output is 0. So if Q is 0, that term disappears, and you're just left with $500. So total fixed cost is 500. Q star and P star are simply the profit maximizing price and output where marginal cost intersects marginal revenue. So you just set these two things equal to each other, and that will give you Q star. In fact, you can see my work over here. And once you know what Q star is, this 20, you can put that into the demand equation, and that will give you P star. And then the profit per unit is simply the difference between the price, which would be P star, this thing, and the average cost, which you could get from here. Putting the Q star into this would give you the average cost per unit. This is the selling price per unit, and the difference between them would be the profit per unit. Those are all kind of straightforward algebra questions about the curves. And this one's a little harder. Imagine that total fixed costs were to double. This would cause P star to rise, fall, or stay the same. It turns out it's a little counterintuitive, but it turns out that P star would stay exactly the same because fixed costs don't matter. Fixed costs, they certainly matter whether you make any money or not, but fixed costs don't make any difference in your decision on where is the best place to produce and where is the best price to charge. Fixed costs don't have anything to do with that. Those decisions, that is the location of P star and Q star, comes simply from marginal cost equals marginal revenue. And this is the construction, I can't really show it to you very well, of a firm making normal profit. Remember, it was normal profit. So when a firm makes normal profit, then its price must hit its average total cost, and its total revenue curve must just be tangent to its total cost curve. So that's it. Hope you found that helpful. Good luck.